Hello, my name is Austin Kruzel, and I attend Fraser High School,
Hello, my name is Jedrek Shipman. I attend Lakeview High School.
and this is our related rates project on the Sean Moore situation.
Some materials that you will need to create this diorama include a 13.5-inch by 10-inch shoebox, scissors, toothpicks, a blue ribbon, cardstock in the colors blue, black, and green, cardboard, pictures of the related rates problem, pictures of Sean and Mrs. Hilliard, a ruler, glue, and some writing utensils. To start creating the diorama, glue the green cardstock in 3 distinct areas to cover the majority of the bottom of the shoebox. This is necessary as the cardstock is not the full length of the shoebox. At the top of the box, or the lid, take 2 pieces of blue cardstock and glue them down. Draw clouds by making 3 circles as shown. Make a total of 3 unique clouds by varying the size of each circle. Now, cut out all of the clouds that you have drawn. To create the road, take a piece of black construction paper and cut out a piece that is 1 inch by 11.5 inches, and then cut out a segment that is 3 inches by 6 inches to create the parking lot. Glue the strip of road to the parking lot. Then, glue the finished road and parking lot to the green cardstock. Cut out a large piece of cardboard. This should be 2.5 inches by 13.5 inches. Cut a second strip of cardboard that should be 2.5 inches by 6 inches. Glue the strips of cardboard along the boxes shown to create small houses.
Since this picture is above average size, take 2 toothpicks and tape them around the back of the cutout photo. Place the Mrs. Hilliard cutout on the edge of the road and hot glue it down to the cardstock. Take a protractor and draw a 10-inch straight line from 30 degrees north of Mrs. Hilliard's travel path, which is the road. Make the roofs by drawing quote-unquote random triangles. Measure the distance between the edge and the middle of the triangle, and once you have that distance, copy that distance over to the other side to make the roof a symmetrical triangle. Wrap 2 toothpicks vertically with tape, one on top of the other, and these will be taped around the large Sean cutout. As shown in the footage here, the doors vary, which is like the clouds. So vary the width and the length of each doors and attach them as necessary. You can make as many as you want, like the roofs. You want to cut 2 1-inch by 1-inch cardboard squares. Now these will slide around the Sean configuration to secure him and make him movable, and that will be shown later on. As shown above, you want to cut through that 10-inch track there, which will ensure Sean can be moved as necessary. Glue the roofs and the doors that you cut out earlier. Since we encourage varying all the roof sizes, all the roofs, at least their lengths, must add up to be 13.5 inches, which is the length of the shoebox. The clouds and the prompt, which had to be cut out earlier, are now going to be glued in the sky portion, which is the top of the box. So you're going to want to glue the 3 clouds as shown, or you can glue them in any random assortment as you wish. Since this is the MSCC parking lot, you're going to want to draw lines as shown here. You're going to want to leave an opening for the entrance, and you're going to want to do this on the opposite side of the box as well, the side near the wall. Now here's where you're going to want to be using those 1-inch by 1-inch cardboard pieces that you had to cut earlier. So you're going to want to hot glue a toothpick to one of the cardboard pieces, and you're going to want to insert it through the bottom as shown here, through the line you had to cut on that 10-inch track. Now then you're going to want to place another 1-inch by 1-inch cardboard piece over the top of the toothpick. And then once that's secured, the toothpick in place, you're going to want to hot glue a cut rubber band on top of the piece and glue it to the other side near Mrs. Hilliard to complete a triangle. Sean's distance is decreasing. Sean's distance is increasing.
Mrs. Hilliard is leaving MMSTC after a long day of work. Mrs. Hilliard turns left out of the parking lot. After driving for some time, she realizes that she needs to look up directions, so she stops after traveling 46 meters. A few moments after Mrs. Hilliard stops, Sean Moore enters his car. Sean intends to take a left turn like Mrs. Hilliard, but he's having a sugar rush from 2 sips of a McDonald's Coke and instead moves 30 degrees north of Mrs. Hilliard. Sean is traveling at a speed of 11 meters per second. Find the rate of change between Sean and Mrs. Hilliard when Sean is traveling 51 meters from the school.
Okay, so solving this problem requires, of course, well, a diagram to visualize it. So here in the top left, we have that diagram. So with Mrs. Hilliard, she traveled 46 meters and then she stopped, so her rate of change is 0. With Mr. Moore, he's traveling 30 degrees north of her because of his 2 sips of McDonald's Coke. So, of course, he traveled 51 meters, and at the time of this, he's traveling 11, which is his rate of change. And so that distance there is what we need to find. And so because this isn't a right triangle, it's explicitly 30 degrees, we have to use the law of cosines to calculate the missing side and derive it to find that rate of change. So over here, you can of course see the law of cosines to just find the other side, and plugging all of these different values in, especially in that second line there, you can see 51 squared plus 46 squared minus 2 times 51 times 46 times the cosine of 30. And of course, with that, you get 25.566 meters. So down here, this is the law of cosines, and right here, just to contrast that, that is the derivative of it. We have to use implicit differentiation. So of course, with the power rule, you just do 2 times dx dt, and then you write all of that out. And then the hard part is at the very end there, where you have to do the triple product rule, which is x prime times y times z plus x times y prime times z plus x times y times z prime. And then so you plug in all these values, and you simplify, and you simplify again to get a rate of change between Sean and Mrs. Hilliard of 50.684 meters per second. Thank you everybody for listening, and does anybody have any questions? I I hope you don't, because this is a video and I'm not going to answer them.